Welcome to Anywhere Math. I'm Jeff Jacobson, and today we're going to learn how to solve inequalities using addition and subtraction. Let's get started. All right, before we get to an example, let's do a little experiment. So if I have an inequality, 3 is less than 5. Well, of course that's true. 3 is definitely less than 5. We know that. Now, what happens if I add something to both sides? The same thing. Let's say I add 2 to both sides of that inequality. Well, then I would get 5 is less than 7. Is that still true? Well, yeah, 5 is less than 7, right? So that's still true. After adding the same thing to both sides of the inequality, it stayed true. Let's do that again, but this time, instead of adding 2, let's subtract 2. So if I subtract 2 from both sides, then I get 1 is less than 3. Well, is that still true? Yeah, 1 is still less than 3. That's pretty obvious. So with this information, hopefully you can see that if we add the same thing to both sides of an equality, it stays true. If we subtract the same thing from both sides of an equality, it also stays true. So let's keep that in mind and let's try an example. Here we go with example 1. Solve and graph the inequality. So we have x minus 3 is greater than 1. When solving inequalities, it's just like solving equations. The whole goal is to get that variable alone. We want to isolate the variable, get it alone, where we had the variable on one side and then whatever else on the other. Okay? So to do that, in this situation, I've got x minus 3. Well, I need to get rid of that minus 3. So just like we do with an equation, I'm going to add 3. And like I just showed you, if I add the same thing to both sides of the inequality will stay true. So kind of like the golden rule with solving equations, anything I do to one side, I have to do to the other. So if I add 3 here, I also add 3 on the other side. So that minus 3 and plus 3, those cancel out, become 0. So I just have x is greater than 4. Okay, that is my solution. Now, if I wanted to check that, just pick a number that's greater than 4. Well, how about 5? 5 is greater than 4. So if I take that 5 and I substitute it back in, well, 5 minus 3, is that greater than 1? Well, yeah, 5 minus 3 is 2, which is greater than 1. So that works. So that is my solution. Now it's time to graph. So to graph, it's pretty simple. Just draw my number line. I always like to start with a 0. And then I've got 4. Now, x is going to be greater than 4. It's not greater than or equal to, so that means it's a open circle or open dot, and it's greater, so it's going to the right. So there is my solution, and there is my graph. Here's some to try on your own. Example 2. Again, solve and graph the inequality. We have 15 is greater than or equal to 6 plus x. My goal stays the same. I'm trying to get the variable alone. I've got this 6 that I need to get rid of, so I'm going to subtract 6 from both sides. Those 6's will go away. I'm left with x. I got to keep the sign the same, just like that, and 15 minus 6 is 9. So I can read this as 9 is greater than or equal to x, but when you graph, you normally want to start with the variable first. So I'm going to rewrite this as x. If I read from right to left, it would be x is less than or equal to 9. So that's going to be my solution. And now let's graph it. So again, make your number line. I'm going to have 0, 9, x is less than or equal to 9, which means I'm going to have my closed circle or closed dot at 9 and less than, so my arrow is going to the left. Okay, there's my solution and there's my graph. Here's something to try on your own. All right, here's our last example. A 180-pound man gets on an elevator that can hold no more than 1,500 pounds. Write and solve an inequality that represents how much more weight the elevator can hold. So, first, let's try to find the important information in this word problem. So, we've got a 180-pound man gets on an elevator that can hold no more than. That's important. That should get us thinking about an inequality. No more than 1,500 pounds. Okay. We're looking to write an inequality that represents how much more weight the elevator can hold. Okay. Well, we're starting with 180 pounds on the elevator, right? The man's on the elevator, so we've got 180. We want to know how much more. Well, if we already have another 180 and we're thinking about how much more, we don't know how much more, so that's going to be our variable. Well, if we're talking about how much more weight, let's call it W. So 180, are we going to add that W to 180? Are we going to subtract? Well, we're looking kind of for like the total weight. So we're going to add that. 180 plus W, that's how much more. All of that together has to be no more than 1,500 pounds. So 1,500 is over here. Now, I got to think, okay, what is no more than? 180 plus W has to be no more than 1,500 pounds. You can think of no more, that's like a maximum. 1,500 pounds is the maximum. We can't have more than that. We can have 1,500, that's okay. So I'm going to have, I know it's going to be or equal to. Now I'm just wondering, is it going to be greater than or equal to or less than or equal to? Well, if it can't be more than 1,500, that means it has to be less than that. So 180 plus W is less than or equal to 1,500 pounds. That's the first part. We wrote an inequality. Okay. Now it's time to solve it. So same thing. I'm trying to get the variable alone. I got to get rid of that 180. So I'm going to subtract 180 from both sides. That 180, those go away. I'm left with, I'll put a line. I'm left with W is less than or equal to 1,500 pounds minus 180 is going to be 1,320 pounds. Okay. So, and I'll put my units in there at the end. So if we think, well, what does that mean in this problem? That means how much more weight can the elevator hold? The elevator can hold no more than 1,320 pounds. Okay, that's the maximum amount of more weight it can hold. Okay, here's one last problem to try on your own. Thank you so much for watching, and if you like this video, please subscribe.